And welcome back. We are going to go ahead and explore a new thing for our code, which is the try-catch mechanisms. Now, we have seen try-catch used before, but now we're going to actually learn about what it is and how to implement it within our programs. Now, the most common thing where we're going to start seeing some of these things with try-catch and exception handling and all these other things we're going to be looking at in this unit, it has to come back to program errors. And we have seen in our programming already numerous examples of if a program encounters an error or let's say an invalid input. Well, our most common solution with that is to simply output an error message and then terminate the program. Like, for example, we say we want a number and someone types a letter and we say, oh, that's not a valid input, and we terminate the program. However, the way to handle that is kind of inefficient and really kind of poor practice if you think about it. Think about if you were running your own program and as soon as there was an error, your program would just crash all the time, wouldn't save your work or anything like that. That would be really kind of annoying and you wouldn't be very efficient or productive with your work. So instead, we want to start looking at this through the lens of separating cases. One way is to divide our task of designing and coding a method is to really have two kind of, if you think about it, main cases. One case where nothing unusual happens. The code runs the way we expect it to. And the other case is what happens in those unusual cases. What are we doing? What are those unusual things that are occurring? Well, once we have our program working for the case where things always go smoothly, this is what we expect, then it's a lot easier to code for when those notable exceptions happen, when things start going crazy. In Java, the way to mirror this is very easy to think about in our code. We pretty much would first write our code more or less as if nothing unusual happens, and then we would add an exception to add code for whatever the unusual case might be. So let's go ahead and look at an introduction to exception handling. The most important use of exceptions, therefore, is to deal with methods that have some special case that is handled differently depending on how the method is used. For example, if there is a possibility of having division by zero in a method, then it may turn out that some invocations of the method, the program should end, but for other invocations, we want something else to happen. Such a method could be defined to throw an exception if that special case occurs. Now, the exception, of course, will permit the special case to be handled outside of that method, because we're not going to write that code inside of our method. We're actually going to have a separate method. We're going to abstract it. We're going to have it out into its own kind of feel here. This is going to allow that special case to be handled potentially differently for different invocations, which is really nice because we don't have to necessarily restrict it to one particular method. We can then kind of define it so the other methods could use the same exception. And when we start looking at exception handling, the way we approach this in Java is going to be kind of as follows. First, we're going to either have some library software or code have a mechanism that signals when something unusual happens. This is often referred to as throwing an exception. Another place in your program, we're going to place code that deals with that exception, and this is called handling the exception. So you first have to throw an exception, and then you have to handle that exception. And by doing it this way, it allows us to have much cleaner code than trying to have all this convoluted things to make things work and all these different exceptions, and it's just a lot easier to separate it out here. Now, exception handling is meant to be used kind of sparingly. It's not something you necessarily have to implement in your code all the time, because obviously anytime you have more processing checks, you can add to computational power, stuff like that. But there are situations that have it where it's pretty reasonable that you should have exception handling. And what we're going to look at here are going to be pretty introductory. So it's not like saying hey, you should have these kind of exception handlings all the time in your program. So the goal here is not to hit you with high-level things right off the bat. Instead, we're going to look at these very simple examples that may not normally need exception handling because you can handle them with just better programming. But because we are still learning about what exception handling is and the various details of Java, just remember that these examples, again, aren't something we would use in regular exception handling. Because they're very, very simple in what we're going to look at. For example, a division by zero is a relatively easy thing that we can kind of work with our code. It's like, hey, if we look and see, for example, if we know that denominator is zero, we can do a simple if statement check to see if it is zero. So that is obviously something we can do. We can have better programming to go ahead and do some of these. However, because again, we are learning how to write these simple examples are going to be very good for us to look at and analyze. So let's start with the first part of an exception, which is the try block. The basic way of handling exceptions in Java consists of the try, throw, catch trio. Now at this point, we're only going to start dealing with try and catch. We're not going to worry about throw just yet. Now we've actually have seen try and catch before when you've dealt with a little bit of file input and output. Now the general setup for a try block consists of a try block followed by one or more catch blocks. So it's kind of like how we think about if-else statements. You have one else block, and then you have multiple if-elses that you can dictate. It's kind of like that, but in reverse. Now a try block has the following syntax: try, and then you have some code that may throw an exception inside of that. So it's pretty easy to notice. There's no parameters or anything like that we have to deal with here. It's simply just the keyword try, some curly brackets, and the code that goes in the middle. This try block contains the code for the basic algorithm that tells the program what to do when everything's going smoothly. All right, and it's called the try block because, well, it's going to try or attempt to execute the case when everything is going well. Now, obviously, there comes times when we don't have things go so well, so we start running into those throwing of the exceptions. Now, an exception can be thrown as a way of indicating that something unusual happens. For example, let's just say if our code tries to divide by 0, this is an arithmetic exception that gets thrown. Now, initially, we're going to use this with some Java classes and some of the built-in ones that are available. In fact, we're going to use the arithmetic exception here in our example today. But eventually, we're going to get to the point where we're going to be writing our own exceptions, creating our own exception code that's going to handle things a little differently. Now, as the name suggests, when something is thrown, something goes from one place to another. All right, we're moving how our code and objects and everything are being handled within the program and putting them through a different way to try and process it or get new input or whatever we want. All right, this going from one place to another is the flow of control as well as the object, the exception object that is being thrown. So whether that is one type or another, we'll look at some of those here in just a minute here. But again, the thing here you have to remember is that when you get an exception thrown, it's not necessarily staying at that same exact block anymore because it's now moved on to the next part of your program. And that part of the program is what's known as the catch block. So when you throw that exception, the code in the surrounding try block stops executing. All right, whatever it has where that encounters that first thing, it's going to say, "Oh, there, this is not right. What do I need to do?" And it's going to look at all the other portion of code right down to the catch block and start running that code. And the catch block is going to be a little different than our try block. So like I said, remember how I said it's like the opposite of an if-else statement. When we have an else, it doesn't have any parameters, but ifs and elses do. Well, the catch blocks also have parameters. And the exception object is then thrown, plugged in based upon whatever parameter is plugged in there. The executing of the catch block is called catching the exception, or sometimes handling the exception. When an exception is thrown, it should ultimately be handled, or in this case, caught by some type of catch block. And again, you can have multiple different type of catch blocks. All right, and so now we have the try block, we have the catch block. This is all feeding together into a full mechanism that's going to work for our program. Now, the catch block is very, very simple in how it works. It's always going to be after the try block, kind of like we talked about if else is always at the end. If the try catch, the catch is always afterwards. And this is just an example one. Catch, exception E, string message goes E.get message, system.printline message, system.exit 0. Now, this catch block, if you kind of think about it, almost looks like a method definition that has a parameter type execution. Because you think about, this is our method name, this is the parameter being plugged in. By using our type exception, though, all right, this catch block will catch any possible exception that is thrown. Because we're specifically using the class exception here. There are other types that we can look at later on, but in this case it's saying, hey, any kind of exception that gets thrown, we're going to call this right here. Now we can also, again, like I said, we can restrict it to specific classes, and we'll see more of that as we get further on, but right now we're going to go ahead and use just the exception class. Now the exception class, of course, is one of those things that we kind of need. All right, it's part of our handlers of code. The catch block, like I said, it looks like a method, but it is not a method. Even though we treat it very much like a method in some ways, it's a separate piece of code that is executed when the exception is actually thrown from our try block. And if we look at that previous example, all right, what's it going to do? Well, that previous example is simply just going to print out a message about what exception was thrown. So it's not necessarily solving the problem in this case, but we're simply, again, we're just learning about how this mechanism works first before we try addressing all the different pieces of it. Now, when an exception is thrown, it is similar to a method call. Like I said, it's like a method, but it's not. But instead of calling a method, it calls the catch block and says to execute whatever code is inside of it. And a catch block, therefore, is often referred to as the exception handler because it's handling whatever exception that you've set up. Now, with the catch block parameters, if we look at that, we have a little identifier inside of that catch block, exception E. What is E? What does that actually mean? Well, E is simply just a parameter. It's nothing really special. You can have, at most though, one catch block parameter. So no matter what type of exception you have, it's always going to have one parameter. And so a lot of times, just for most conventions, we'll say exception E because it's a common one that gets used because E stands for exception. Now, although the identifier E is, again, often used, it's not required to be. You can technically use any non-keyword identifier. So, for example, you want to call it except, you could call it except. You could call it pretty much anything that you want. You could call it, anything, just like a variable. Yeah, because that's really ultimately what it is. It's just a name of this parameter type that you can plug in. Now, what is the purpose of having this parameter here? Well, it's going to ultimately do for us two things. The catch block parameter is preceded by an exception class name that specifies what type is thrown. If the class, of course, is called exception, it can handle any exception. And again, we're going to look at later how to do this for more specific ones. And the catch block parameter is going to give us a name for the thrown object that's caught, so we can then write code in that catch block that does things with it. So, for example, we call it E, and then, of course, we were able to do like E.getMessage, so we were able to print out some of that stuff. Now, when we actually look at the execution of the catch block, there's two possible cases what happens when a try block is executed. The first case, of course, we have no exception thrown. And the second case is that, we've thrown something in the try block and then it's going to be caught within the catch block. Now, there is technically a third case where the catch block does not catch the exception, but we'll explore that later. So right now, we're primarily just going to focus on these two scenarios. All right, what happens when no exception is thrown, and what happens when we throw an exception and we catch it. Well, if no exception is thrown, the code in the try block simply just executes as normal, goes to the end of the try block, we skip the catch block, and do whatever other code we want to do within our program. Now, if the exception is thrown within that try block, well, the rest of the code in the try block is skipped, and in most simple cases, control is simply transferred over to a catch block. All right, it's like, I threw an exception here, let's go right over to the catch block. Awesome. Well, then the thrown object is therefore plugged into the catch block parameter, and the code in the catch block parameter is then executed. Then, provided that the catch block code does not end our program or do something else to end it, such as system.exit 0, well, whatever code follows the catch block would then be executed. But if you, of course, for example, say system.exit 0, you're terminating your program, and you won't have anything more happen. All right, so real quick, let's go ahead and just write up some real quick code just to show how some of this works. So let's just go ahead and say we're going to get two integers from the keyboard. So int num1 equals kb.nextInt. And let's go ahead and do int num2 equals kb.nextInt. And let's probably add a quick prompt in here since the print line. Please enter two numbers to divide. And then what we want to do is then, of course, write the code that would happen. Now, up this point, none of this code could trigger an exception. But what we're about to do is have something that could potentially trigger an exception. So let's go ahead and do that. So if we go ahead and say num1 divide by num2, all right, this is, of course, going to potentially trigger that exception. And what do we want to do with this? What do we want num1, num2? Well, let's just go ahead and put that inside a system.out.println. All right, we're just going to print this out. All right, so we're going to divide these two numbers here. Great. Well, if we run this as normal, and we say, okay, we're going to run our program here, and let's just say we do 4 for our first number and 0 for our second number. We get an error here. It says that we divided by 0. How can we handle it? How can we make it so our program doesn't crash anymore? Well, let's just go ahead and add in a try catch block. So we're going to just move this one line of code, because that's the thing that causes the error, into here. And then we're going to go ahead and do a catch block. And we're going to just use exception E. All right, because we can, of course, use this more specific one, arithmetic exception. But this is just a generic catch-all, and we're just going to do a system.out.println. And we can say divided by 0. All right, and if we try to run this program now with this, let's do 4 and 0 again, you see that we no longer have a crash. We no longer get the error message because now it's been handled by this. Now we could use that specific one, which was the arithmetic exception here. So if we change it to this arithmetic exception, you'll notice this is still going to work again the same way. So 4 and 0 divided by 0. But what's if I wanted to do another one? So I could do, for example, catch, and then I could do my exception E. And this will also work the same way. So just do system.out.println. And we're just going to go ahead and say not a valid input. So for example, if we go ahead and type a letter here. So for example, let's do 4 and let's do the letter A. Oh, we get an exception here, input mismatch. So not a valid input. So this one didn't get quite caught here. All right, so we want to go ahead and match this. Now, of course, the exception E didn't catch us, which means if we might have to move these around a little bit to try and get these working. Now, notice it didn't like that because now it's saying, hey, move this catch clause here. All right, because it's saying this doesn't work. All right, so we are going to back this up just a little bit here. And if I change this back to just a plain old exception E, let's go ahead and rerun this now. Let's go ahead and do 4 and A. We still get that same error because, again, remember, this is just a general exception. So if I want to handle this input mismatch one, it's very, very easy to do. So I can just go ahead and come in here, add this input mismatch, exception, E. All right. Oh, it helps if I spell it right. There we go. Input mismatch exception. I can even copy what this is. Now notice it's still saying, I don't know what you want me to do with this. All right. It says I have to import this. So this is a class that doesn't exist. So I have to import that as a utility. And you see now it imports that. And so now I could, of course, just go ahead and copy this here. I'm just going to change this one to some other error. And if we run this, so let's do 4 and A again. All right. We're still throwing that exception because it's giving us this here. But if we add in the system.exit 0, let's try this one, 4 and A. All right, we're still going to get that exception here. And that's okay because we haven't yet talked about how to handle this in all situations. And we're going to get into that. So for now, though, let's just go ahead and assume that we're going to get the correct inputs with what we're doing. But I just wanted you to see that how easy it is to set this up. Again, we haven't quite addressed everything of how we can handle all these different exceptions. But for most of what our purposes are, having something just with a simple try catch like this, if I go ahead and run this, 4 and 0, some other error, perfect, this works. And that will, of course, get us enough to kind of get started with.